Welcome back to the Mechanical Literacy Project. Today we're going to be talking about bolts, bolt parts, and plastic and elastic properties of bolts. So stay tuned and we're going to jump right into this thing and get it over with, but it's kind of boring. So just stay with me and I hope you're going to find some interesting, useful information. So let's go. Welcome back to the Mechanical Literacy Project. I'm Jack, and we're going to be talking bolts. There is so much to cover that this is going to be a multi-part series because there's, like I said, so much to cover. Today we're going to talk about just the basic construction of a bolt and just a few other things here. What I have here in my wonderful little fastener bag is some half-inch bolts. I believe they're half-inch. Yeah, they're half-inch. So what I got going here, this one that you see right here, this is a 1-inch, and bolts are determined by their size by the diameter of the shaft, not by the head size. You have somebody comes in with wants a half-inch bolt, and it says a half-inch bolt because it takes a half-inch wrench. That's not a half-inch bolt. So for example, here's the half-inch bolts. Let me open up a pack here. And what I have are fine thread bolts and coarse thread bolts. And we'll talk about that too. These are the fine thread bolts. The fine thread bolt is stronger. The thread pitch. This is called the thread pitch. They're a stronger bolt. This is a grade 8. It's designated by grade 8 because it has 1, 2, 3, 4, 5, 6 of these little lines. A grade 8 bolt is harder than a grade 5. And I have some grade 5 coarse thread bolts here. Let's dig into those. This is a grade 5. It has 1, 2, 3 lines. That designates it as a grade 5. If it has no lines, that's a grade 2. Farmers a lot of times call them a butter bolt because they're softer metal. We'll get into some of the forces that affect bolts. But right now I'm going to talk about the bolt construction. Okay, this is called a hex cap bolt because it has a hex head that takes a socket or a open end or a box end wrench to activate it or to tighten it down. So this is the head. In here, let's see, let me get a piece of white paper back there so you can see what's going on. Just below the shaft. Okay, just right where the head meets. Let's see if we can get up close. Okay, let's see if we're going to focus on it here. There we go. This doesn't come to a tight square corner. It has a little radius to it. And the reason that is that's to relieve stress. If this were just a straight corner on this, it would be susceptible to shearing off a lot easier than with the radius. They do this if you ever seen a crankshaft on a car and the journals where the connecting rod hooks onto the crankshaft. They machine those journals with a little bit of a radius, just a little curve to it. I don't know if you can see it better here in this big bolt. You see it here. See if I can make this a little lighter. You can see what's going on there. So, anyway, this is not a square machine off of it. It comes off at a little bit of a curve. So you have the head. You have the radius. That's this part right here. And then the smooth area from here to here is the shank. This is also known as the grip length. Now then you have the threads, and where the threads stop, that's called the run out. And then this is the thread length. And from the base of the head, not the top of the head, but from the base of the head to the end of the bolt is the nominal length. So you want a 3-inch bolt, it's going to measure 3 inches from here to here. Let's see, these are, well, let me show you the label here. I'm going to explain this label real quick. So this is, let me get this a little darker here so we can focus in. Okay, there we go. So this is a 1/2-inch bolt. In other words, let me grab the right one here. The shaft is a 1/2-inch diameter. 20. Okay, this is the thread pitch. This is 20 threads per inch by 2.5. That's the nominal length from here to here. 8, that's a grade 8, and then these are just some codes that they use. We won't get into those, that's not really important. So you have a 1/2-inch diameter, 20 threads per inch by 2.5 from there to there. So that's how you size a bolt. These grade 5 bolts that I have is over in the picture here. These are 1/2-inch again, diameter, 13. There's only 13 threads per inch by 3.5. So that's from the base of the head to the end of the bolt. That's if you got the size of a bolt. Now what's really important to know is the shank, the grip length. So when you're going between two pieces of material, you want to make sure that your shank is what is holding the material. That's the strongest part of the bolt. The threads are not as strong shear-wise, and we're going to talk about forces now. There's some various forces that affect bolts. And the first one is a shear. Let's see if I can have, I think I have some material here that shows the force. There's shear force, there's tensile strength, and then there's torque. So here's a diagram of the shear strength. So what happens is you have your loads. You have a load going one way, a load going the other way, and it's secured right where the loads meet. It's secured by the smooth shank of the bolt. That's good. Now if you look at this other example, this is a shorter bolt, and the shank only comes partway through half of the load, and where the load shears is where the threads are, and this will no doubt break right there. You get a load pulling that way, a load pulling this way. So that's shear strength. The shear load is two forces that move back and forth. Now then we're going to get into tensile strength. And here's a handout I got from online. I think probably Wikipedia or something. But anyway, you can look this stuff up too. Anyway, this tensile strength is the strength that pulls on the bolt. Now bolts are also called fasteners. So anyway, it's the strength that pulls on the bolt. And even though the threads, these are the same size bolts, the threads on this are finer. This actually has more holding power than a coarse thread. Even though the threads look thicker, these threads don't look as thick. This has more strength when pulling on it. As far as the shear strength of a grade 8 compared to a grade 5, Grade 8 is better for shear strength. It's just, well, let me put it this way. It has more tolerance to withstand a shear load. Now, sometimes you don't want a bolt that's going to be like that. Sometimes you want a butter bolt. I have a field mower on my tractor, and it has a shaft in it, and the shaft drives the gearbox. Now, the bolt that's going through the shaft that drives the gearbox uses a number 2 or grade 2, or what they call a butter bolt, to connect the shaft into the coupler. And the reason that they want a real soft one is if I hit a rock and it stops those blades, you're going to break a $2 bolt rather than a $200 gearbox. So that's important. In fact, I was kind of unsettled here a while back. I loaned the mower out to a buddy of mine who is a machinist, a maintenance mechanic, and he should know these things. And it came back to me with the grade 8 bolt in it. So apparently he sheared off that bolt for some reason and put a grade 8, which I like, okay, that wasn't a good thing. But anyway, it came back to me and it was intact, so I wasn't upset. So now you have the tensile strength. That's the stretch. Trying to figure out how to explain this. If you go back into 3rd or 4th or 5th grade back in school, you learned about simple machines, and basically a screw or a bolt is just an inclined plane, if you remember the inclined planes, but it's wrapped around a shaft. Simple explanation. So the more you tighten this down, the harder it's going to stretch. Now, I'm going to talk about this bolt being elastic. You're going to say, what? It's steel. Yeah, it's steel, but it's also elastic. Elastic is actually a property. You think of, well, let's see. I have a piece of wire here. Okay, so you have this piece of wire. You're going to hold this. Let me get a good background so you can see what's going on here. So here, I'm going to explain the elastic properties of metal. That bends and it comes back to its memory. Metal has a memory. Okay, so you're gonna flex it and you're gonna let it go, and it's gonna come back to where it wants to be, where it was. Then when you get into past the elasticity, it's called the point of yield. You tighten this down too tight, and all of a sudden you're going to feel the wrench kind of give a little bit, and you're going to go, oh, that didn't feel right. It's not tightening anymore. What's happened is you've stretched this bolt past its elasticity. So you stretched it past this elasticity into plasticity. Now your bolt is basically ruined. It's not going to return to its shape, and that's why a lot of especially like in engines in high-tech fields, aeronautics and marine, they specify using new bolts, even though the bolt they took out of something was just fine. Well, they don't want to have that chance that that bolt actually went past its point of elasticity. Now you're going to see this isn't going to go back to its original shape. So anyway, this is I guess part 1 of my series on bolts. I gave you a little explanation of sizing. I have another video out that tells you what size wrench to use on bolts, and that's kind of a humorous anecdote. Is a lady asked me one time what size what size wrench to use on a bolt, because it didn't tell her on the end, and so I'll get into that in my other video. So anyway, we're going to, real quick, you got the Hex Cap Bolt, measured by the diameter, the length from the bottom of the head to the end, and the thread pitch. Those are the 3 dimensions. Your stress forces are shear strength, and tensile, that's the stretch. And then there's one final stressor that they look at on bolts, and that's torque. So you're tightening a bolt down. Let's see if I can get a, I don't know, see if I can get a socket or something here to show you kind of what's happening. So you're tightening down the bolts, and you go past, well, let me get the nuts out here. And then when you go past the point of elasticity, and then that's called the point of yield. And that's a very important thing to learn. So you're tightening this thing up. You got your wrench on there, and all of a sudden you just feel it give. You feel that that wrench or that socket, whatever you have on there, all of a sudden it'll just give. And it's like you get a little sinking feeling in your heart. You go, oh, what did I do? So that's why it's important on some applications to use a torque wrench. A lot of stuff you don't really need a torque wrench, but it's recommended. On this video, I'm recommending it because just for legal things, you want to make sure you're using the right torque specifications. One other quick little thing here, I have a couple of these. These are called gauges. They're a hardware gauge. You can see this is a 1/2 inch bolt, which is real close to a 12 millimeter. Almost, but not. There's a 1/2 inch bolt. Gives you your bolt size, and then, well, unfortunately it's broken off, but over here it gives you your thread pitch. Is the 1/2 inch one is broken off here, but you would hold it up against the edge and it would tell you your thread pitch, and then of course your bolt length. This big old bolt here is a 1 inch bolt by 24 inches. It's galvanized, and I don't know where I got it. Somebody gave it to me. And one interesting thing, because it's a galvanized bolts have a little different thread pitch, because a galvanized fastener adds a thick layer of protection onto the bolt, so it prevents it from rusting. Hopefully prevents it from rusting. If the galvanization gets compromised, then that part will rust. So anyway, because there's a thicker layer of galvanization on the nuts and the bolts, they actually have a little bit different thread pitch. They still have coarse and fine threads, but you need to use a galvanized nut on a galvanized bolt. If you try it, you're going to see it doesn't work. If you try to throw a galvanized nut on a plain bolt, or a plain nut on a galvanized bolt, it just doesn't work. So anyway, there's a little heads up on that. Anyway, I hope you got some good information off of this video. I'm going to get into some more details on the next one. We're going to get into some different type heads on these bolts. Besides the hex head, they have socket heads, carriage bolts, plow bolts, elevator bolts. All these have different types of heads. Machine screws have different heads: round heads, flat heads, pan heads. So in the future here, we're going to get into that. But right now, I just wanted to get you guys familiar with the basics of bolts. The strongest point is right here. If you think about like you're going down the highway and you look up and you see the big power towers that hold the electrical lines, those are put together with rivets. And all a rivet is just basically this part of a bolt, the smooth part, that's been has a special head on one end. It's rounded usually, and then the other end, as it goes, they put it through. They usually smash it with a mechanical, with some sort of a machine that'll smash the head on the rivet. But if you notice, rivets are smooth all the way along, and that's the idea behind a machine bolt, is that it's going to be a smooth shaft that holds your two pieces together. There are cases where you have a long bolt similar to this, and it's threaded all the way up, and that would be something that it's not going to have any shear force. It's going to be working this way. It'll just be a tensile strength, but they need a long bolt for whatever reason, and it's threaded all the way up. That would be called a tap bolt. Anyway, again, I hope you got some information. I know it's kind of boring stuff, a little dry. Anyway, whether you want to or not, I'd sure appreciate it if you'd hit the like button. It helps me get some more videos out. And again, this is just the first part of this video. We're going to get into the threads and thread pitches and thread strength later on here. Loads, yields, and some other information. So thanks for watching, and I just appreciate it again. Hit the like button.